So I'm a walker, so you got to forgive me. So we hope this is an interactive session. We have plenty of time. Believe me, we're going to run out of slides way before the hour's up. So don't be afraid to ask questions or to expand on some areas. We have, my role is I really am right now running kind of the OpEx part of our MES system. So we've got 7,000 active users in our data collection system for what we call a device history record. So when you make a medical device, you have to write down how you make it. And it's a regulatory requirement. You have to keep that basically forever. And there's a lot of information in there. And, you know, manufacturing, you know, if you look at the supply chain, we have feeder plants that send to other plants, and pretty soon you end up shipping an MRI. Well, all that data and chaining all that data together is quite a challenge. So we have a couple of challenges. One, we control it with some pretty strong workflows, which is a whole nother presentation. And then we want to do analysis. Now, analysis, you know, could be millions of rows in our current database, and with the structure of it, that can really be a challenge. We also have other data, maintenance and calibration data. So, you know, all this stuff is auditable when the FDA comes a-calling. And it really is just answering the question, do you know how you built it? Do you know how you maintain it? And most of us have children or something that's been in like an MRI or something lately. And, you know, you talk about the regulation. Well, how good do you want that machine to be when you put your child into it? So those are some of the questions we constantly ask. I thought this really had a lot of truth in it. So we're going to have consultants say that 3 quintillion bytes of data are created every day. It comes from everywhere. It knows all. According to the book of Wikipedia, its name is Big Data. Big Data lives in the cloud. It knows what we do. In the past, our company did many things. I do think my company is not evil, so I crossed that out. But we accept big data if we accept big data in our servers, we will be saved from bankruptcy. Let us pay. I just thought that was too good not to include. And there's some truths in it. We have, if you could analyze all your data, you would know so much more. But the challenge is how do you slice it and dice it and get it to the right person? And so that's where we're really trying to start down this road. What I hope to tell you about here is kind of where GE Healthcare is at with respect to the data warehouse, really engineering and manufacturing data. Talk about a proof of concept that we did with Teradata's MLDM and you know, some of the results there. Kind of review where I hope we go in 2013, and as you know, we're still in the budget season, so you never know. And then ask some questions. After we spent all this money in all these companies, we haven't got what the functional teams want, and why? And I think that's something, a little bit of self-review is good on that one. Our current data warehouse really focuses on the business side of things. Finance, orders, when did we deliver what? It really doesn't do much for manufacturing and engineering systems. For engineering, we really use single non-data warehouse sources for analysis. So we're a supply chain that's 3 years old, and we have maybe, let's say, 300-400 major products. Well, every one of those major products has their way of analyzing the data and their tools. There's a lot of duplication in it. And they have their data structure, et cetera. Besides, you know, we want to add the testing, which is really the custom side. We have a common device history record. Pretty common in about 70 sites, as my first slide said. And, you know, we collect, it's not a lot of data by your guys' standards, but we collect 200 or 300 million rows of the operator telling us what's going on. Well, that's a reasonable amount of data that's pretty important for us. And all the big machines in hospitals, most of them feed back information. And we capture that information, but it's in some different systems, and the utilization of that really can be challenging, and it's some older technology. So we kind of hope to develop, to start with developing an engineering manufacturing repository that kind of has those three basic pieces in it to start with, and to be able to build this up. We also have occurrences where, wow, some of the data due to storage space may be taken offline. So if you're trying to do analysis, all the data's not even there to do analysis. So it's very difficult for someone to do this analysis unless they really have a reason to do it. Why hadn't BI really focused on manufacturing? Well, first of all, the finance people get to decide what you buy. That's always a given. But we really don't talk money if you get down to the engineers and you get down into the people that are making the tactical decisions. They're looking at their CPs and CPKs and the max entries that they get from different devices and stuff, and they're trying to figure out what's going on. So it's a very nuts and bolts situation, and you got to really figure it out. They're not looking, roll-up's good, but immediately they want to dive down into the detail, because telling them it's bad, well, they probably already knew that. You got to try and figure it out. And my point number 2 really is it's hard. We're talking about going through a lot of data. We're talking about data that could include images and analysis of the image, and where did you put the image. Then our third point, we make a lot of different types of products. We make many thousand blood pressure cups a week in Mexico. Pretty simple process. They come out, bam, bam, bam. We also make MRIs. Not so simple. Now, we want to have one manufacturing system to analyze both of these. We know it's difficult to have one size fit all, but that's really what we're going to do here, is try to develop a system that we can lay all this data in and normalize this data and develop one set of tools and really get some good business benefit. So in 2011, we did a POC, moving some of our device history information into the MLDM. So how this started is I went to Dan and we were talking one of those talks, and we had purchased the MLDM, but nobody was using it. So I kind of said, hey, why don't you do a POC for me? It's supposed to be really easy to do, so you must be able just to throw the switch and put this data over and report on it, and we'll all be happy. Well, after Teradata went away for a while and came back and says, we'll do that. And so what we really wanted to find out here is, does this thing really work? Does it look like a tool that's better than just the glossy brochure? Because I'm really kind of the show me type of guy. I've done this for a while, and it's easy to say the big words and use, the big 3-letter acronyms, but it really doesn't work. It's too hard as soon as you unwrap the box. The other thing we're interested in is to be able to really do the SPC, statistical process control, on lots and lots of characteristics at once. We know we have several million characteristics. And what happens if you wanted to calculate a CP or CPK for a large number of those, or recalculate something? And, would it work? The other thing, believe it or not, we really didn't have any world-class analysis tools in use on this type of data. And most of the people, the vendors are downstairs here. And so we wanted to show using one of those tools against the data that they put in the MLDM. And that was really going to tell us a few things. First of all, hey, you can hook it up. It's pretty easy. You don't have to go through an intensive, huge project just to get the tool to work, and just how complex it would be. So the last thing is we wanted to propose an architecture for storing all engineering and manufacturing data. So how would this work? How can we come up with something that is kind of affordable and looks like it will work, something we can manage? And this was a key here. Hey, you did it one time, but when we're looking at this, we know this is going to be a multiple generation project that goes on and on. We're going to pull in a few products at once, a few pieces at once. So can we have a flexible architecture that will work? Oh, by the way, we've got requirements like you can't take this data out of this country because it's illegal. How are we going to handle that? We have some places that save a test, and I don't know if you guys are familiar, but you go get an x-ray, and you have the old way is they would put a piece of film under your body and shoot x-rays through you and develop the film. Well, we make a digital x-ray detector. It's like a big digital camera that they shove under you, and it develops an x-ray. Well, these are pretty high tech, and they're really interesting, but every one of those that ships has 50 gigabyte of data behind it. So now, I want to move 50 gigabyte of data, let's say reasonably frequently. I don't want to bring it over the WAN. So how can I put an affordable device in this plant and let those engineers use that data, yet it's available for calculations for things like CP, CPK, what's the quality level of it, how much production did I do, retests. How can I bring that up into the bigger engineering data warehouse with the right amount of data, but yet have the official data storage, because, by the way, we're regulated, so we don't lose that data. Keep it local in an affordable way. I also met with Teradata and other consulting people to kind of look at some plans and stuff and see what we could do. And it worked out pretty well. So this is just a screenshot, and I don't have a lot of them. This is of Tableau with the data in it. So this was a huge win. I mean, we had a tech show where they had a server under a desk, and they were walking around with an iPad. And I think they only had 350 or 400,000 rows. Not a lot of data, but you're walking around with the iPad, and they could click the different buttons, and the charts change and recalculate pretty fast. I mean, I was pretty pleased here. I think it's a little interesting. I happen to know a little bit about that data. If everything was perfect, those numbers would be the same. And this is the type of thing that, I don't want to say it's literally worth $1 million, but there were times it was. So first of all, I'm not going to talk about the stuff on the right. As you probably figured out, I'm not the technologist here. Never will be. My guy gets really nervous if I ask for the database login. What are you going to do with it? I'm just going to look. What are you going to do with it? So when we talk about reporting, this gets mixed up with lots of people, from technical people down into the functionals for sure. Always talk about the structure of the data and how are you going to store it. And then how are you going to visualize it? And that's two conversations. Certain tools work really, really well depending on the type of reports you're putting out there. And it fits into the other reports. So if we're using OBIEE, for example, for a series of reports, if I add one more report to this guy's bucket, we don't want to use a different tool. And so we try to right-size the tools, not reinvent the wheel there. And that, I can't believe people, they make this, they confuse this. They always confuse the visualization tool with the reporting effort. And it's hard to get money for the structure. That's the problem. Our little POC here, summary. We end up using 81% standard MLDM. And oh, by the way, when I gave Teradata the data, we were doing this huge release, and I told them we don't have any time to work with you. And literally, I don't know, an hour or two is all that my guy gave to them. And they did a real good job of fitting the data together. There was a couple of places that if we'd been working with them that they wouldn't have did something custom, they would have used standard, and that was just about verbiage differences and things like that. But I was real pleased, 81% standard. We estimated about 100 or 150 more hours to come up with the schema that we would use for all device history records. Well, that's not that much time. I really could define exactly how I'm going to store all my device history records with another 100 hours of consulting and be a huge win. We were able to enable SPC, and we enabled Tableau, and we had an architecture that was proposed, which I'll kind of show you in a second. We consider it a success. So in 2013, we were looking at what do we want to do.